Hello guys. In this tutorial we will learn about a new classifier, that is your naive Bayes classifier. In our earlier tutorial we have studied about LR classifier, and after that now we are learning a new type of classifier, that is naive Bayes classifier. Now what is that? Naive Bayes is a technique used to build classifier using Bayes theorem. So actually, in this, we are using the Bayes theorem, and that's why its name is naive Bayes. Now, what is Bayes theorem? So, Bayes theorem describes the probability of an event occurring based on different conditions that are related to this event. So, basically, this theorem is describing the probability of an event based on different conditions that are related to that event. So, we are actually using the probabilities of that particular event, or we can say in our algorithm we are using different features. So that's why we are using that theorem in our algorithm for building classifier. Now see, the assumption here is that the value of any given feature is independent of the value of any other feature. So this is the main assumption which we are assuming here, that we have different features, and feature from that list is not dependent on any another feature. And that is called the independence assumption, which is the naive part of a naive Bayes classifier. So given the class variable, we can just see how a given feature affect it regardless of its effect on another feature. So basically we are seeing just that feature and that feature effect on that class variable, and not we are seeing the relationship between different features here. So this is the important assumption which we are assuming here, and since we are using Bayes theorem, so that's why its name is naive Bayes theorem, or we can say naive Bayes classifier. Okay, now let's take an example. For example, an animal may be considered a cheetah if it is spotted, has four legs, has a tail, and runs at about 70 mph. So, what we are assuming here, that we have seen an animal, and if we are seeing these features, then we will assume that it will be a cheetah. What will be the features? It will have four legs, it will have a tail, and it will run at about 70 miles per hour. So these are the features, and cheetah will be the animal for which is representing those features. Now, what is the use of naive Bayes classifier here? So, a naive Bayes classifier considers that each of these features contribute independently to the outcome, means these features are not depending on each other, and they are contributing independently to the output. The outcome refers to the probability that this animal is a cheetah. Now, here what will be the outcome? The outcome will refer to the probability that this animal is a cheetah. So it is actually referring to the probability, and that's why its name is naive Bayes classifier. Since we are using a probability term, and the probability here is that the animal is a cheetah. We don't concern ourselves with the correlation that may exist between skin patterns, number of legs, presence of a tail, and movement speed. Now we are not seeing the relation between those features, and we are seeing only that particular feature, and we are assuming that it is a cheetah animal, and we are giving that probability that this animal is a cheetah, and that's why this classifier is being used here. Okay, so that was your naive Bayes classifier. Now let's see how to build a naive Bayes classifier in Python. Okay, so let's see a program in Python for implementing or you can say for creating a naive Bayes classifier. Okay, so this is your program. First, I'm just okay. Now see this program. Now first step is to import modules. So here we are importing your NumPy module, Matplotlib, sklearn, and utilities. Now you know very well that what is utilities here. Utilities is your class, and in that class we have defined visualize classifier function, which we have seen in our previous tutorial in LR classifier. Okay, now see why we are importing here sklearn module, because we want here naive Bayes module, which is inbuilt module present in sklearn module, and from that we are importing Gaussian NB. Now this is that classifier which is actually using Gaussian distribution, and that's why we have used here that module. Now first step, we are taking input data, and for that our data is present in our input file data multivariable nb.txt. So we have taken this file in that input file. Next we are loading data from that file, and for that we are using load.txt function of numpy module. And then here this file is containing comma separated values, and that's why we have used here delimiter equals to comma for getting data. And then we are loading our data into that data variable, and then we are applying the slicing operation on that variable so that we can get data in x and y variable. Okay, so that part was your taking input data. Next step is to create naive Bayes classifier, which we want to create here. So in this type of classifier, we assume that the values associated in each class will follow a Gaussian distribution, and that's why we have used here Gaussian NB function. Okay. Next, we are training our classifier using fit function, and then we are applying predict function on our classifier for training data. Okay. Next, we are computing our accuracy, that how accurate our classifier is. And for that, we are using this function. Okay, and this next we are printing our accuracy of that classifier using round function up to 2 decimal points. Okay, next we are visualizing our performance of the classifier using visualize classifier function, which we have defined in our utilities file. So that was your normally creating classifier. Now what is the limitation of that? Now if we want a perfect boundary, then that will not give the correct boundary, or you can say a rough boundary. It will give a rough boundary. So now we need cross validation. So we need to perform cross validation so that we don't use the same training data when we are testing it. So now we are splitting our data into training and testing data set. And for that we are using train test split function. Okay, then we are again creating our classifier using Gaussian NB function, and then we are using fit function, and then we are using predict function for training our data set. Okay, training our training data set. Next, with what we are doing is we are computing again accuracy, and we are using the same function which we have used earlier, and then we are printing our accuracy, and then finally we are visualizing the performance of the classifier. So basically we have visualizing here performance two times, first the normal classifier, and then we are splitting our data set into two parts, test training and testing data set, and then we are again visualizing its performance. Okay, now next, we have some inbuilt function for getting accuracy and other scores and all, like F1 score. And so let's see those functions. So we are using here cross validation module and cross val score function, in which we are passing our classifier whose performance we have to evaluate, and we are passing our input samples x and y, and we are passing here scoring argument. So when we want accuracy, then we will pass here accuracy as an argument, then we will get here accuracy. Next we are passing here precision weighted as an argument in scoring, and then we are getting the precision values as precision and for the classifier. And next last we are passing F1 weighted for getting the F1 score, or you can say F1 score values of our classifier. So using these three inbuilt functions, we are printing our output, or you can say we are getting the performance of our classifier. Okay, so now let's run this program. Okay, now see this. First, we are not splitting our data into training and testing data set, and in that case we are getting that type of plot. Now see here accuracy is 99.75%. and we have here four different groups of our data set. Then we are splitting our data set, and in that case we are getting the perfect boundary, and where the accuracy we are getting the accuracy as 100%, so that is more accurate. And at last we are using our inbuilt function, and for and when we are using our inbuilt function, we are getting the accuracy, precision, recall, and f1 as output. So these are your final performance of your classifier. Okay, so and that was your output, and that was your program. Now you can build that classifier on any data set that you want and create different boundaries like that. Okay, thank you.